What do lawyers and mathematicians have in common? Well, both of them have a job that involves proving stuff. Now, up until now, you've been applying a lot of mathematics and you haven't come across proof and derivation very frequently. But a cornerstone of mathematics is actually coming up with all these formulas and theorems that we use in order to solve problems. So let's have a look at the derivation of the formula for an arithmetic series. So, an arithmetic series, we know, is the sum of the first n terms of an arithmetic sequence. And the formula for the arithmetic sequence is Tn equals a plus n minus 1 times d. So we're going to start by substituting in for the terms in that series expression, right? So that a plus 0d is the first term, and we get it by substituting 1 into our formula for the sequence. So a plus 1 minus 1 times d is a plus 0d, term 1. Term 2 ends up being a plus 1d. Term 3, a plus 2d. And then term n minus 1 is a plus n minus 2 times d, and term n is a plus n minus 1 times d. Okay, so we've made a good start here. What's next? Now, I'd like to draw your attention to the a's there, right? Now, the question is, how many a's do we have? So we have an a from term 1, an a from term 2, an a from term 3, an a from term n minus 1, and an a from term n. In other words, we have n a's in that expression there, all added together. So we can write that at the front there as n times a, meaning we've got a number of a's equal to n. Right, then what's going to happen is the magic trick, right? Now each proof has a trick, a moment where you look at it and you go, ah, that was really clever. And this is our clever moment for this proof. What we're going to do is we're going to take that expression and we're going to add it to itself. And what we're going to observe is that something really cool happens, right? So we've got there na plus na, right? And we know that's going to be equal to 2na, not too difficult, right? Then what we're going to do is something a little sneaky. We're going to take that 0d at the top and add it to the n minus 1d at the bottom, right? And we're going to get n minus 1d. Then we're going to add the 1d at the top and add it to the n minus 2d at the bottom. And the answer, n minus 1d. We take the 2d and add it to the n minus 3d, and we get n minus 1d. The n minus 3d goes to the 2d, we get n minus 1d, n minus 2d to 1d, n minus 1d, and n minus 1d to 0d is again n minus 1d. So what happens here is that every term at the top has a partner at the bottom that you can pair together in order to get n minus 1d as the result of adding them up. So what happens is that we have an n minus 1d at the bottom there for each and every term at the top, right? So we've got a number of n minus 1d's equal to n. We've got n minus 1d's, right? So we can write that then as n times n minus 1d. Same as what we did for the a's. If we had n number of a's, we can write it as na. So now we've got n times n minus 1d. And then we've just got to add up Sn to Sn, and that's 2Sn. Not too tough there. And then we find that 2Sn is equal to 2Na plus n times n minus 1d. Right, so that was actually the hard part. Now we've just got to do a little bit of algebra, right? So the first step there is to take out a common factor of n on the right. So that becomes 2Sn is equal to n times 2a plus n minus 1 times d. And then all we're going to do is divide both sides by 2 so that we isolate Sn. That's what we're looking for. And we find that Sn equals n over 2 times 2a plus n minus 1 times d. And that there is the formula that you should be familiar with, which means we've been successful in deriving the formula for the arithmetic series. Right, now, in summary, the trick to this proof, that magic moment you've got to remember where they do something clever that makes the whole thing work, that is writing out the series and adding it to itself. The steps you're going to follow is to write out Sn. You're going to collect all the A's at the front as Na. You're going to add Sn to itself, and then you're going to solve the resulting equation for Sn. And there you have it, the derivation of the formula for an arithmetic series. So now you know how to apply the formula, and like a proper mathematician, you know how to derive it as well.